In this video, we're given a bunch of right triangles with some unknown angles, and we want to find the value of those angles. So in this first example, our unknown angles are marked by theta. So we have theta here, and we have theta here. We want to find the value of those. And to do that, we need to set up some trig ratios, and I always like to use SOHCAHTOA to help me do that. And the first thing that we need to do is identify the opposite, the adjacent, and the hypotenuse sides of this right triangle. So the side that's across from theta is always the opposite side. So that's going to be 11. I'll say O for opposite. The longest side of this triangle is the hypotenuse. So 13 is going to be the hypotenuse. And then the remaining side, we'll say A for adjacent. And to set up our trig ratio, we're going to use the sides that we know. So we know the opposite side here, that's 11, and we know the hypotenuse side, which is 13. And the opposite and hypotenuse go with sine right here. So I'm going to set up my expression. So as you can see, the equation will read sine of theta equals 11 over 13. Now, a common mistake here is sometimes I'll see some students divide out this sine as if we had multiplication right here, but that's not right. To get the theta, we're going to use the inverse of sine, and that involves raising sine to the negative first power. That represents the inverse, and then we're going to plug in our fraction on the right side of our equal sign. So that's going to be 11 over 13, and that's going to give us the value of theta. If I do this in the calculator, I'm going to get theta be approximately, we're rounding here, it's going to be about 57.8 degrees. Now in part B, we're going to do the same thing. We're going to identify the all the sides. So across from theta is 6, that's going to be the opposite side. The longest side here is going to be the hypotenuse, which is H, and then the remaining side curves over here, that's the adjacent side, which is labeled as 12. So as you can see, 6 is the opposite side and 12 is the adjacent side. We're going to use the two sides where we know the values for. So opposite and adjacent, it looks like we're going to use tangent. So I'm going to set up that equation. So we're going to have tangent of theta equals 6 over 12 because 6 is the opposite side and 12 is the hypotenuse. I'm sorry, the adjacent side. And we're going to use the inverse just like what we did over here. So we'll have the inverse of tan, and that just means writing tangent with a -1 as the exponent. And then we're going to do 6 over 12. And that's going to give us about 26.6, and we're rounding that to the nearest tenth. So that's going to be my final answer, and that's in degrees as well. Okay, on to this example. It's just like the other ones, but we don't have theta. We're not given that, but we do need to know all the missing angles. So in this situation, we don't have angle A. We got to figure out what that is, and we don't have angle B. We have to figure out what that is. So to start, let's go with angle A. And I'm going to identify all my sides that I know here for angle A. So I know that the longest side here is the hypotenuse. That's going to be 14. And then the side that's next to angle A is the adjacent side. That's going to be 12. So we have the adjacent side and the hypotenuse. And I'm going to bring back SOHCAHTOA here to figure out which trig function I'm going to use. So since I have A and H, that means I'm going to use cosine here. So I'm going to set up my equation now. So in this situation, instead of writing theta, I just write the capital A that represents our unknown angle A. So we have cosine of A equals 12 over 14, and I'm going to use the inverse again. So the inverse of cosine of 12 over 14 is going to be angle A, and I'm going to calculate that. If I round to the nearest tenth again, it's going to give us about 31.0 degrees. So that's going to be unknown angle A, which we now figured out. Now to get B, I'm going to use my trig ratios again. Our 14 right here is still the longest side of my triangle, so that's going to be H, that's my hypotenuse, but now our other sides change. So now 12 is the side that's across from angle B, so that's the opposite side. So now 12 is going to be our opposite side. So we have opposite and hypotenuse. And the trig function that goes with opposite and hypotenuse is going to be sine. So now I'm going to use sine of angle B. So there's my equation right there. It's sine of B equals 12 over 14. I'm going to bring in the inverse to solve for A. Oops, I mean solve for B. We already solved for A here. So the inverse of sine of 12 over 14 is going to equal B, and then we use our calculator to get that answer. And when I round that, it's going to be about 59.0 degrees. Now if you're thinking, well, do we have to do trig ratios for finding both of these angles? Well, no, not necessarily. Before we did all the work for finding angle B, we knew that angle A was 31 degrees, or about 31 degrees. Well, we also knew that we had a right angle right here. That's going to be 90 degrees. So if we knew that that was 90 degrees, and then we knew that angle A was going to be about 31 degrees, well, you could subtract those two from 180, and that would give us our remaining angle of B right here, because all angles of a triangle add up to be 180 degrees. So you could have done it that way, and that would have given you 59 degrees as well. Now over to part B, we're going to do the same type of stuff. We're going to find angle A first. So here's angle A, and we see that the side that's across from angle A is 3, and that's going to be our opposite side, so we're going to use that side. And then our hypotenuse is the longest side, which is right here, but we don't have a value there, so we don't want to use the hypotenuse. We do have this leftover side over here. That's going to be the adjacent side, so we're going to use the opposite and the adjacent side here to set up our trig ratio. Which one are we going to use? Well, O and A match up with tangent, so we're going to use tangent. And here's my trig equation. It's going to be tangent of angle A equals 3 over 7, and remember that's opposite over the adjacent. And I'm going to use my inverse to solve for angle A, so let's go ahead and set that up. So there's our equation. We have the inverse of tangent of 3 over 7, that's going to equal angle A, and I use my calculator to get our answer. And that's going to be approximately 23.2 degrees. Okay, so that's angle A, and we're going to use the other, so like we could go ahead and do another trig ratio like we did here to figure out what angle B is, but we have our 90-degree angle right here. Let me draw a line there. That's 90-degree angles, or 90-degree angles. That's a 90-degree angle, and we know that angle A now is 23.2 degrees. Well, we could subtract these two angles from 180, and that is going to give us our last angle that's unknown, which is B. So I'm going to do 180 degrees minus 90 degrees minus 23.2 degrees. And that's going to give us about 66.8 degrees, and that's going to be angle B. So we have all three angles.